So this is part 3 of the population biology lecture, and we're going to start with reproductive strategies, something that we discussed in the first couple slides of the population biology lecture in part 1. But what this is about, species have different reproductive patterns. You'll hear it said a couple different ways. Some people will say are selected species, some people will say are strategists, because again, this is their strategy for reproducing for optimum success. Now, in our selected species, they are opportunists. We said before that the R, the little r, stood for your biotic potential. So a species that has an R selected strategy tends to reproduce at very, very high rates. Again, they're opportunists. They're going to make use of all available resources in their area. They tend to be generalist species as well, if you remember that from ecosystem structure. But again, our selected species reproduce very quickly. That R, I always think of roaches, rodents, rabbits. That little r, those little reproducers, little r, biotic potential is really what it stands for, but I always think of it as standing for reproduction. A K-selected species, or a K-strategist, however, these tend to be your larger organisms, and what that big K really stands for is the carrying capacity. These organisms are competitors. They invest quite a bit in their offspring and their young, and so their strategy for surviving is to have just a few individual offspring, but to make extra sure that those offspring are able to survive. Most mammals tend to fit in this category because they care for their young. You do see, however, some mammals that reproduce very, very rapidly, again, usually in that rodent population, that don't tend to care for their offspring for as long. You've got extreme cases like the great apes, human beings, which care for their offspring for many, many years until that species, or I'm sorry, until that offspring is itself able to reproduce, even in the case with humans. But a K-selected species, again, you don't have very many offspring, and you want to make sure that those offspring survive. So where we see this, it tends to be that an R-selected or an R-strategist species has that exponential growth. Although all species can, these just take off very quickly. What we tend to see, though, the difference is that an R-selected species will overshoot its carrying capacity and have a dieback. K-selected species go through the process of reproduction much more slowly and tend to have large or long gestations. And when they approach that carrying capacity line, they start to feel the stress of the zone of intolerance. It might be as with human beings where you approach that carrying capacity limit. Let's say you are malnourished. Women who are malnourished have a much more difficult time going through menstruation, going through their natural monthly cycle. And so it becomes much more difficult to have a birth occur. So K-selected species are much more aware, whether that's cognitive or not, are much more likely to respond to the approach to carrying capacity. So when they're approaching that K line, we tend to see them level off into a logistic growth curve. Part 4 of the lecture about survivorship, and this is once a species is there, what are they going to do to make sure that they survive? And the animations really do a great job speaking for themselves, but before I get to that, we're going to talk briefly about what you see here in front of you. The number of survivors is going to be on the y-axis, your age is going to be on the x-axis, and what we see with type 1 is that at birth, everybody's a survivor. Now that's true for all of the graphs. But at birth, we have a large number of survivors, and as time goes on, we see that most individuals of the species are living to old age, and then we start to see a dramatic drop-off. This would be like human beings. So most humans are going to survive their early years, and then maybe when we hit our teenage years, we make some unwise decisions. Maybe there's some diseases that might get some teenagers, but generally, It's not till midlife that we see the death rates sharply take our lives. And so that's when we have things like cardiac arrest setting in and cancers. So type 1 is a great representation for humans and other large mammals. Type 2 is a little bit more, it's a more interesting scenario. The book gives you the examples of lizards and songbirds as something with type 2. And the way to think about this is when you're young, there are some things, some tragedies that could befall you as a lizard or a songbird. Let's take a bird, for example. You could be pushed out of the nest as an egg by that cowbird we talked about, that nest parasite. Or there could be something else coming along in just a few more months. Maybe you have a hard time flying and you can't make it out of your nest, and so you die. A little bit later on in your life, maybe you are taken by a cat, maybe you hit a power line, maybe you go through a jet engine, who knows? But at any part of your life, you are just as likely to pass as at another part, and that's a type 2 survivorship. Type 3 survivorship is more common with our R-selected species. Those R-selected species throw lots and lots of babies out into the world in the hopes that only a few of them will survive. A fantastic example of this is the sea turtle. Sea turtle can lay 200, 300 eggs, but only a very small percentage of those will make it to the ocean. If they make it to the ocean, they've got a decent shot of survival. But again, most of the offspring are going to be taken here at a very early age. And so we see that if that turtle is able to make it into its teen years, into its middle age, then it has a very strong likelihood of surviving for a very long time. So I'm going to play this animation for you, and that's the last thing of this lecture. They will explain it a little bit differently. And make sure this is in your screencast. Okay.
This curve reflects a fairly constant death rate at all ages. This curve reflects a high mortality. Or no parental.
And that's the end of the lecture.